Hi everyone, to help out with these U substitution problems, I figured I would just go through a bunch of them. I'll go through 1, 5, 9, 13, 17, and 21, and then maybe I can do a couple other ones if I see fit, okay? So, here we go. On number 1, the integral of 1 plus 2 to the fourth power, x plus 2, to the fourth power dx. To do this problem looks like, it's supposed to look like a integral of u to the 4 du, right? Because if that's the case, if I just knock that out, call that just a variable u, we know how to take the integral of that. So we're going to say u is equal to x plus 2. So this is the process of u substitution. Always call out your u. U is equal to x plus 2. Well, if I have u, then we need to take the derivative, because we need to get that dx to become a du also. So let's take the derivative of u and of x plus 2. I'm going to write it out this time. Take the derivative of u, and then we take the derivative of all of x plus 2. The derivative of u is just du. We take the derivative of x plus 2. We separate that into two derivatives. Remember the rule. We need to separate the derivative plus the integral. Integral I'm talking about. Plus the derivative of 2. The derivative of x is just dx, and derivative of 2 is 0, okay? So in this case, this is what I like calling a no-cost substitution. dx and du just translate without anything else. I don't have to bring a 2 with me, I don't have to bring an x with me, I don't bring anything with me. This integral of u to the fourth power, and then the dx, we said, dx became a du. And that really gives us back what we wanted over here. Okay, so we just take the integral. Integral is u to the 5 over 5. How did I do that? Remember, it's the power rule, which is our plus 1, 4 plus 1 rule. That becomes our 5. Yes. I don't know why I wrote the integral. That goes away, I'm sorry. And since this is a indefinite integral, we have to remember to plus c to it. And that's the answer. Oh, sorry, we have to resubstitute u for x plus 2. So let's double check our work. We're not going to always do this, but let's go ahead and double check our work right now. And let's take the derivative of our answer. What if I take, what is the derivative of x plus 2 to the fifth power over 5 plus c? What is that derivative? Well, we take the derivative of this guy here first. That's going to be power rule, bring down the 5. X plus 2 to the fourth power, because we minus 1 to it from power rule, all over 5. Chain rule says, what's the derivative of x plus 2? That's just going to be 1. And what's the derivative of a constant value c? That gives us 0. Let's clean this up. It'll be x plus 2 to the fourth power, which is back to where we started, right? That's our answer from back. That's the answer from where we started. And that's where we started over here. Oops, my mistake. So we start right there. So you can always double check it by going back and plugging it in, by taking the derivative, and see if we get the answer we originally should have started with. Okay, let's do number 5. Number 5 goes, the integral of dx over 2x minus 1. And you can also write this as, if you want to look at it easier, is integral of 1 over 2x minus 1 dx. I feel like this might be a little easier because this actually matches one of our integral rules. And our integral rule, the rule is the integral of 1 over u du is equal to natural log of u. Okay? And plus c. If you look at your list of rules, this is one of our integrals. And to go forward, just to talk about it, the derivative, d over dx, of ln of u is equal to 1 over u. Right, that brings us back here. That's our derivative rule. That's our derivative rule. Okay, let's go ahead and do our u substitution. U is equal to 2x minus 1 du is equal to derivative of 2x is 2 dx, and derivative of 1, since it's a constant, equals to 0, right? 0. Looks like terrible 0. 0. So we're left with, we want to solve for dx, so that's what we're going to substitute. So every time I see a dx, I'm going to write a du over 2 instead. Okay, let's go ahead and plug it in. The integral of 2x minus 1 is now a u, and 1 over u, and dx is now written as du over 2. Let's go ahead and take the 2 on the denominator out. So 1/2 integral of 1 over u du, which is back to our identity. It goes to 1 over 2 ln natural log of u plus c. And we know what our u value is. Please write that back in. Natural log absolute value of 2x minus 1 plus c. And that's our answer. Okay, let's do problem number 9 now. Integral of x over the square root of 1 minus x squared. Can you guys guess now what my u probably would be? Would it be the x on top or the 1 minus x squared on bottom? Well, obviously, it's probably the more difficult thing. Usually it's whatever is buried inside. If you look on my left side over here, let's look at the possibilities. If you look at number 9, that would be my u, 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 that would be my u. See, so it's usually the stuff on the inside. And let's see if you guys can take the derivative quickly. The derivative of e to the x is e to the x. Let's look over here. Sorry. Do it that way. The derivative, let's look at this one here. The derivative of e to the x is e to the x. That would divide out. The derivative of 1 minus x squared is negative 2x, and this would divide out. Let's look at number 10. X squared minus 1, the derivative of x squared minus 1 is 2x, and the x squared and x would divide out. Let's look at number 14. Sine x, the derivative of sine x is cosine x. That would divide out. So let's look at 18. X squared plus 1, is derivative is 2x. The x will divide out. Looking at 17, derivative of 1 minus x squared is negative 2x, and the x's would divide out. Number 21, the derivative of x cubed plus 1 is 3x squared, and guess what? The x squared divides out. So us taking u substitution is actually one of our easier ways to get back to our identities, back to the integrals that we do know. Okay, so let's go and finish up these last examples. U is equal to 1 minus x squared. Just to talk about where our goal is to make this integral of 1 over the square root of u probably, but that is not an identity that we know. So we change this into a power rule. So it's the integral of u to the negative 1/2 power. The 1/2 here is our radical, and the negative is because we're in the denominator. So let's go ahead and finish up the problem again. So it's du, derivative of u is du, derivative of 1 minus x squared, derivative of 1 is 0, and the derivative of negative x squared is negative 2x, and then don't forget to do chain rule. Derivative of x is dx for us, and dx is equal to negative du over 2x, because we divided it to the other side. Let's go rewrite our integral. Integral of x on top, the square root of u, and dx became du over 2x. Put a negative there. And if you see now that the x and the x divide out, our goal is to be in only one variable. That's going to be 1 over the square root of u, du. No other variables left. Okay. And we're going to go ahead and finish up the problem. Negative 1 over 2. Rewriting this as integral as we did talk about up here, as u to the negative 1/2 du. When we do power rule, that's plus 1, negative 1/2 plus 1. Negative 1/2 u to the 1/2 over 1/2 plus c. Now talk about this again. This is 1/2, negative 1/2 plus 2 over 2, which leads us to positive 1/2. Let's go ahead and rewrite back our u value. These end up dividing out. Negative the square root of my u value back here was 1 minus x squared. 1 minus x squared, we can write that right there. 1 minus x squared plus c. Now, just to prove this to you, why do we even have u substitution? It's really because of chain rule. When I take the derivative, you end up with that u. We end up with the chain rule value, and let's demonstrate that here. Negative 1 minus x squared. We'll write that as a 1/2 exponent plus t. And let's go take the derivative of this. The derivative of a negative is a constant multiple, so that's negative 1/2 1 minus x squared, and then we're going to minus the 1/2 by 1. That's going to give us a negative 1/2. Our chain rule value, right, what's the derivative of this, is negative 2x, and then the derivative of the constant, is going to be 0, so we're not going to write that anymore. Let's simplify this problem. If you notice right here, the 2 and the 1/2 divide out, leaving me an x on top and a negative 1/2 here, which means it's on the denominator. So it's going to be x on top over the square root of 1 minus x squared. And if you look back on question number 9, that was where we started from. So our whole point is that because of chain rule, we end up with this extra value, and u substitution allows us to take into account for that extra value from takes into account of that chain rule problem. Okay. Let's do one more. I'm gonna jump and do something that looks hard, but not really. We'll do number 12. Number 12. The integral of x sine of x squared dx. Now, I want you guys to make a quick guess. What do you think my u value would be? Would my u value be the x squared or the x on the outside? Now, part of being able to identify u value problem really quickly is that take what you think is going to be your u. In this case, let's say it's going to be our x squared. And what's the derivative of x squared? 2x. And does a 2x divide out the x? Yeah, that's going to clean it up for us. And that's the hint of how do you know it's going to be a u value, u substitution problem. So let's go ahead and say u is equal to x squared. Du is equal to derivative of x squared is 2x. Derivative of x is dx. Dx is equal to du over 2x. Let's substitute everything back in. X sine of u. And then dx becomes du over 2x. And you notice we get rid of the x's that we wanted. We're left with the 1/2 in the front. That's a constant for us. Integral of sine u du, which is back to our identity. We know that identity. Integral of sine is cosine, but careful, it's actually going to be negative cosine. Negative cosine of x, cosine of u, I'm sorry, plus c. In this case, if I multiply the 1/2 by the constant, it's not just another constant. We never said what the constant was going to be, so we can leave it as 1 minus cosine. The u value is going to be x squared plus, 1/2 in the front. Let me rewrite that nicer. Negative 1/2 cosine of x squared plus c. That's our answer. Okay, hopefully you found this helpful. If any questions, leave a comment. I'll try to get to those comments.